And this one. Okay, so that might be better. You should be able to see me, right? I don't know. Um, Anyways, so we're going to talk about the approximation of the bond's duration and convexity. So just like we said, we are going to approximate. The keyword here is the approximation. So let me put on the text and choose a nice color. So the keyword here, oh dear, maybe this one, much better. So approximating. Why do we need to approximate? Didn't that we last time we have done teaching, learning how to do duration and convexity? Remember, we have the very complicated formulas and everything just seemed to settle, right? So once you know the modified duration, you can do what? You can take the modified duration times the change in the yield, okay, and then that will give you percentage change in the price. And if you need the dollar change in the price, then equal to the percentage change in the price multiplied by the initial price. So everything looks just fine. How about the convexity? If we know the convexity, which sometimes can be quite big. Okay, so we just multiply by 1/2, and then we take delta y squared. So that is going to give you the correction oh, um, due to convexity. Okay, so now why on the earth do we, well, we have learned how to do um, from the coupon, rate, from the yield, from the price, from the term and everything else to get the duration or modified duration and the convexity. Why do we need to approximate these duration and the convexity? Isn't that there is a formula? Well, the reason really is sometimes the structure of the bond is so complicated that you cannot rely on a consistent yield measure. So when a yield is not consistent or the structure can be disrupted, let's say if it's a callable bond or if it's a puttable, that it can be stopped. And so usually when we calculate the yield, it is really the yield to maturity, right? So if instead we are going to have a callable or puttable or convertible bond, then these bonds can be really changed, or it really depends on what the holder or the issuer was thinking at the time. So the yield to maturity, which assumes that you're going to hold the bond until maturity, may or may not going to really, it may not going to. You may or may not have it realized. So you may or may not hold it all the way until maturity. So in that case, we will have to have a way to approximate the duration. Instead of calculate it from the yield change and the resulting price change, we are going to approximate it just from the approximate interest rate change and the difference of the price. So how do we calculate the difference between the price? Well, we can still use the timeline. So all these are just like the PVBP. Remember the present value of a basis point that we calculated with the price difference. If you have 1 basis point different in the 1 basis point change in the yield. So here, when we're talking about the approximation duration, it's a little the idea of closer to a PVBP, except for we're not just getting the present value difference of a 1 basis point change in the yield to maturity. Instead, we are going to approximate the duration and the convexity. And once we get the approximate duration and the convexity, we can still approximate further the percentage change in the price for other possible price points. So the point is that, hey, it's not that I'm going to do the price change, which is a part of a deal here, and then go from price change to duration and go from duration back to the price change. That's like in a loop, right? Back and forth. What's the point? The point here is that once we can approximate the duration, we can use it partially as a comparison to other bonds, and then partially that we can use it for approximation of the percentage change in other price points. Okay, so formula is fairly simple. We have price minus price plus. Oh, it's a little bit awkward, right? So the price minus is the price if you have a little bit yield change down. Remember, when you have a little bit yield change down, this price should be greater than the price when you have the yield shift up a little bit. Well, yield shifting up and yield shifting down are all in the step of changing the yield delta y, and all of them are going from the basis point or from the benchmark point of the initial yield. So you take that difference, you divide it by 2, divide by the initial price point, and divide by the change in yield. So the change in yield is the delta y is the change in yield used to calculate the new prices. Okay, so if you want to do a approximation of convexity, well, that is a little bit different. It basically is a second order. So you're going to have a 2 here, and P plus P minus 2 of the initial. This 2 factor is very important. Divide by the P again. Okay, so let's take a look at an example. Somehow the sequence is not doing very well. Let's see here. So coming back to this particular example, remember we have PVBP. Just one moment.